Hey guys, we're here for video 7, and today's topic is going to be percent yield. We'll discuss percent yield, actual yield, and theoretical yield today. There is, I believe, one more video in this unit, and it's going to be a lab prep video. It's going to help you to do that lab that's coming up a little bit faster and expeditiously. But we'll talk more about that later. That is not on your tracker. I'll announce that in class. Anyway, as for lab or video 7 on percent yield. Before we can talk about percent yield, we have to talk about things that make up percent yield. So we have theoretical yield and actual yield. Theoretical yield is the amount that we expect to make, and actual yield is the amount that actually comes out. So a good example of that is the Pillsbury dough rolls, okay? Now they have them where you can actually have the little cookie shapes already shaped out. That actually helps to increase your percent yield, and we'll talk about that in a minute. But the tube of cookie dough, when it first came out, if you think about it, it has like the 2 twisted ends, and on the side of the container it usually says something like it can make 2 dozen cookies or 24 cookies. But whenever I make them at home, it never is 24. It's usually about 20. Well, I started to ask myself what was going on with that, and I realized that I kind of eat a spoon, and there always winds up being some stuck at the ends where you cut off the roll. And then some little spoons are bigger than others. So the point is that my theoretical yield of 24 is not what I actually make in the lab. Now this happens a lot in the kitchen in this case. Percent yield not matching, or rather your actual yield and theoretical yield not matching, is actually rather common. When we're in a laboratory situation, sometimes our beakers are dirty, something might react, and not react all the way, and so what we receive out of reaction isn't actually what we would expect. They're not the same. And so percent yield, the equation for percent yield, relates those two things. So we have the equation for percent yield, which is actual over theoretical times 100%. So in the case of my cookies, that would be the 20 cookies that I received, my actual, divided by my 24 theoretical times 100, and then I would stick percent on the end of that. That is what's going to help me to calculate my percent yield. And if I'm correct, that comes out to what? 4 times 5, about 90% roughly in there. I did some series rounding in there, so but just so you know, that's kind of how the process works. So we're going to apply this process to an actual lab situation. We have learned how to take a balanced equation and use that balanced equation to predict how much we're going to make in the lab or in a scenario. All of those numbers that we've come up with from 12.2 and the beginning of 12.3, those numbers are theoretical numbers. Now we're going to get into what those theoretical numbers, how they compare to the actual that's found in a lab. So here's a problem for you, and pause, write it down, and then I'll show you how to answer the question. The way I'm going through this question is going to be abbreviated. It's going to assume that you understood the concepts from the earlier videos. So if you did not understand those concepts, make sure you go back to videos and review them. I would say probably video 5 forward would probably be the ones that are most helpful for you in this situation. So when potassium chromate is added to a solution containing 0.50 grams of silver nitrate, solid silver chromate is formed, and then they give you the equation. The question is, first determine the theoretical yield, and next, if I receive this amount, 0.455 grams, what is the percent yield? Pause and write this down. So your theoretical yield is the number that you already would expect to find. So in all this time that we've been doing calculations, all this time that you've been solving from moles to moles, mass to moles, mass to mass, all of those stoichiometric problems, each time you actually were solving for the theoretical yield. You just didn't know it. So when it says determine theoretical yield, we're just going to solve. Now, because we look at the next problem and we can see that eventually they're going to want grams of silver chromate, we're going to focus on grams of silver chromate. So in the next one, which I've done all in blue to address question A, we can see that I start out with my equation. My known is the 0.500 grams of silver nitrate. I will need path A, then E, then A. I found the molar mass of silver nitrate, then the mole ratio from the chemical equation. than the molar mass of silver chromate. Be very careful not to leave out the 2 in the silver chromate equation. From that, I can set up my math. What I'd like you to do is to see if you can set up the math and then look and see if your math matches mine. So pause here, see if you can set up what the actual setup would look like. So let's look at what I got. We have 0.55 grams of silver nitrate in the first block. Then, because that's our known. Then we put in our molar mass. We need the grams at the bottom so that it can cancel. In our next block, we actually have the silver chromate, the molar mass, the mole ratio, 1 on the top and the 2 moles of silver nitrate at the bottom. And then on our next section, we would have the molar mass of the silver chromate, which is 331.74. And if we do all that, multiply all the way across the top, multiply across the bottom, and then divide by the top by the bottom, then we'll get the answer. So when I multiply all the way across the top, I get these 2 numbers. Across the bottom are these 2 numbers. That adds up to that. And all in all, my answer here is 0.48819 grams of silver chromate. From there, I need to put that in scientific notation. And that is my theoretical yield. So this is a normal section 5, video 5, video 6 kind of problem. Now let's talk about the next part, which is figuring out the percent yield. So in the other problem, they tell us that we have 0.455 grams of silver chromate, that we obtain that from the reaction, and they want to know the percent yield. Well, our conversion factor in this case is actual over theoretical times 100%. We discussed that earlier in the video. So all we're going to do is plug in. Our actual is what we obtained from the reaction. That goes on the top. Our theoretical is the theoretical amount that we found in the last part. So it looks like that. We multiply by 100, so we literally, in our calculator, take this divided by this times 100, and we wind up with 92.21%. We, in this class, don't give any more than 1 decimal place to our percentages, so it winds up being 92.2%. Next, we have a problem for you to try, and we'll start out class with this problem. So give it a good go, and then make sure that if you're stuck anywhere that you make notes that you're stuck and at what steps you're stuck at, so that when we go over it in class, you actually have a fighting chance. Remember that part of learning something that is new and something that is interesting, well, not even interesting, difficult would be the right word, or shares a different perspective, is to constantly go back and to identify where you're confused and to resolve those issues. Sometimes resolving them means to look in the back of the book and to see what the answer is and to figure out how you got a different answer. Sometimes that means looking at an example in the book or looking at an example that was given in class, and it can even mean raising your hand during the discussion of this question to make sure that you get the concept. If we do not address your concept in class, it's important that you ask the question so that we can get that issue resolved. Now, for those of you who have been paying attention, that is awesome. For those of you who've been writing down the problem, that's awesome too. So I'm going to read the problem out for you, and then again, would like you to try this problem at home. Aluminum hydroxide is used in antacids to neutralize stomach acid. You have aluminum hydroxide, these are parentheses, plus 3 hydrochloric acids, which is stomach acid. That gives you aluminum chloride plus 3 waters. That's your equation. Part A. If 14.0 grams of aluminum hydroxide is present in an antacid tablet, what is the theoretical yield of AlCl3? So for that problem, you're going to take that 14 grams of this and try to find the amount of grams of that. Next question. If the actual yield of AlCl3 was 22.0 grams, what was the percent yield? So for that problem, 22.0 grams is your actual. Your number, part from number A, is, or letter A, is your theoretical, and you just plug it into the equation. If you've been following along with the videos, this unit should seem pretty straightforward to you. That doesn't mean that everything always makes sense, but it should be able to see how each class builds upon itself. We've now officially covered all of the new information for this chapter. The only thing that's left is applying it in a lab situation. So make sure that you go back and start to watch those old videos. See if you can solve the problem in advance. So as soon as the problem comes up, pause it. See if you can solve the problem on your own, then watch the explanation. That's an excellent way to get ready for your test. Remember that preparing for a test is not something you do the night before. It's something you start doing about a week out. And we are about a week out from your exam. So you'll want to pace yourself and do a little bit every day to get ready for that. You also can go back over practice problems and problems at the end of the chapter. If you have any questions, feel free to ask in class or send me an email. Have a great evening and see you in class.